Like Rust enables, let's say, ordinary programmers like myself to write extremely high performance code that runs extremely efficiently.
Do you like the small standard library? How do you sort of come down on that?
I don't like the small standard library. It's showing Rust's heritage as the systems programming language. And compared to its peer there, which would be C, Rust is a very rich standard library.
What sort of advice would you give folks that want to go in this sort of maybe like education, training, consulting, coaching type thing? Any advice you have from them that you've picked up over the last year and 5 or 6 years as well?
You need to start today. And that doesn't mean start big. It means start really, really small, because your success will compound. And the compounding effect is going to be much more important than your like current velocity.
Hey folks, this is Alex, and today's episode is with Tim McNamara, and we talk all about Rust, which is great because, Tim is like one of the leading educators in the whole Rust educational space. He wrote the Rust in Action book, which is probably the best Rust book out there if you want to learn Rust. He has a YouTube channel. He taught and did a lot of education of Rust at Amazon, AWS, and things like that. So this was great for me because, I have more of a Python, JavaScript type background, not a lot of systems languages, but he taught me all about object ownership and object lifetimes and just all these interesting things that Rust has and why it is this loved language by so many and why it's continuing to grow. He also gets into what it's like being an independent educator, creator, and, some of the difficulties with that, how to get started, like what, supercharged his whole path and how he deals with doubt. And I just like empathize with a lot of what he said. And I thought it was good advice if you want to go down that path. So check that out. If you have any, questions, comments, guests you want to see, anything like that, reach out to me or Sean. And with that, let's get to the show. Tim, welcome to the show.
Hey, thanks, Alex.
Yeah, absolutely. So I'm excited today to talk about Rust, which is just one of those languages that it's somehow been popular for like 10 years. And it's still like the cool kid on the block, even though it's been around that long. Usually it sort of ebbs and flows and something new comes. But for whatever reason, Rust has just stayed popular. And you are the author of Rust in Action and probably like the number one person people think of for like Rust education and that sort of thing in learning Rust. So maybe just give listeners a little bit more about who you are and your background.
Yeah, hey, thanks, Alex. It's interesting to hear how other people perceive Rust, right? So I've started my own little training organization, a little company that it's little at the moment, but it's actually growing. We deliver training and consulting around the world. And people can find me on timclicks.dev. So you'll typically find me on timclicks. If you search, you'll find me. The interesting thing about Rust, from my point of view, is that its rate of growth is actually increasing. So if you want to be in the top 50th percentile in terms of experience as a Rust programmer, you just need to wait 9 months. Like that's the doubling rate. And that has been the doubling rate since like 2014.
Yeah, it's like quite amazing to see that. And you see like, I talked about being the cool kid on the block, but it's been like the most loved programming language on Stack Overflow for like 8 or 9 years in a row, which is just like so weird because usually it's like these niche languages that like once they start growing and people are like get a little more mixed on, but it's just like it's still continuing to be most loved. And now we have, the White House coming out and saying everyone should be writing Rust or something to that effect. So
yes. So like eventually Rust, so it's going to be a newsworthy event when Rust is eclipsed. Like that's crazy. Like that itself is a signal, right? Like it's like someone finally, like a Zig came along and like knocked Rust off. And you know what? I bet Rust would still be in like the top 5. Like that's still for like a while. And the thing about this most loved and they've changed the wording to most admired in the most recent survey. So if you're not familiar, this is the idea that if you ask, let's say, tens of thousands of developers, what do you program in? And some subset of that say, I program in Rust. And then you say, okay, well, given the language that you currently program in, how much do you want to program in that language next year? And Rust has the highest proportion of people that want to stick with it. Whereas, let's say Java, people, Java is fine. But there's not a lot of people saying, you know what, I really want to be a Java developer next year. it's like, oh, that's what I really want to get into. And I mean, and it's interesting, yeah, that Rust has a vibrancy to it, and I think that comes from some of its descriptions of the way that it speaks about itself. It is an inclusive language. It is an inclusive community. It's in fact, we'll actually talk about some of the controversy that has come out of Rust probably at some point, because there has been a bunch, although I think that's settled down over the last 12 months or so. Rust, if you go on the website, you see, we're there to empower. And that idea that a programming language is there to support you and your goals and to be a coach, to guide you along, is really important. Whereas a lot of other programming languages saying sort of like, I'm neutral. I'm just a tool. You can pick me up and you can put me down. Whereas Rust is saying, no, in order to use this language, we recognize that it's there's a mental burden attached. You need to actually do a lot of hard work in order to get a payoff, essentially. But we're there to support you. And being someone who likes to teach the language, like I find myself I find myself apologizing for the language probably too much. Because Rust has this really interesting trade-off. So I'm not a neutral observer here. Okay, like so the people will say, oh, look, Rust is hard to learn. But what I think that's what a more accurate statement might be: computing is difficult, and Rust gives you that complexity as part of its approach. So the downside with Rust, you get things like ultimate performance, memory safety, some of these attributes that the whole programming industry has not been able to have for decades. And the downside is that some of that, in fact, quite a lot of that complexity is pushed to you as the developer.
I was going to say, it's interesting you see that trade-off in so many places across programming, and it's just like, different strokes for different folks, but you see that in like certain programming language, like I say Ruby just like hides everything from you and just like sort of like goes and works. And like, in that same class of languages, Python is a little more explicit. It's not going to be, forcing you to think about memory as much as like Rust and things like that. But just in that sense, like making things more explicit. Same thing with databases. Certain databases hide more from you. So certain ones make trade-offs more explicit. Web frameworks, all sorts of things like that. So it's interesting, that trade-off sort of just persists. And Rust is, you're saying at that end of just saying, hey, we're going to make everything obvious to you and clear to you, even if it means you have to do more thinking or more work up front. Ideally, there's some sort of long-term benefits to that.
Yeah. So the cost of zero-cost abstractions. So zero-cost abstractions is a term that kind of originated in C++. The idea that if you want to use a language feature, you're actually not going to incur any runtime cost. This was brought into the Rust kind of ethos when it was very heavily adopted by Mozilla to develop the browser that would hopefully compete against Chrome. So that was kind of the origin story of the language, this idea that we need to provide zero-cost abstractions, but the cost of that is cognitive complexity or cognitive overload. And like most embarrassingly for Rust is that this comes out with string handling, and like it's quite it's a very valid joke that like Rust has like 10 different ways to represent text, and this is exposed to you. Like it's ridiculous. But the thing is that at least it seems ridiculous until you think, well, actually, there are 10 ways to represent text, and Rust has a preference for safety. And so if you use text in a particular way, for example, on a file system, you want your type system to treat the path separator, like the slashes or backslashes or forward slashes, depending on operating system, to be handled differently. Because you don't want to make a mistake of like accidentally, weirdly deleting things And Rust does that in the type system as part of its standard library. But the downside is that you just kind of have this like menagerie of different types to choose from. And yeah.
Is that hard? Like, other than the sort of beginner cost of sort of learning those different types, is that like once you've sort of got the model, then it's fairly easy to get that? Or do you even find yourself like switching and be like, you know what, now I've didn't used to use this sort of text type, and now I actually have this new preference, I have new appreciation for it? Or is that pretty settled and clear?
For me, to answer your question, it's not difficult anymore. Like, I actually really appreciate that Rust does some things that are different than other languages. I was a Go developer for about a year and a half. I worked at a company called Canonical. They make the Ubuntu operating system. They're a big Go shop. And the one thing that really irritated me about Go was that the zero value of a type, and for strings, that's the empty string, is treated as equivalent as there being a missing value. Like, there's no real distinction between the zero, the number zero, and like a and undefined, or between the empty string and no string at all. Like, essentially, yeah, undefined, or null, right? Rust makes this very actually makes you choose. It actually requires you to define your type as optional and say this string might not be present. And like, in terms of the big thing that like took me a long time to get, like a huge amount of time really, was this distinction between what Rust calls and it's actually not Rust terminology, but again, Rust was late to the programming language spaces, and so it has used terminology from other places between like an owned string or like an owned type and what it calls a borrowed type. And it's like, oh no, I need to use, I just want to code. I don't really want to like programming language theory. Like, get out of my, it's like, just let me like code my web app. And so allow me to try and explain ownership and borrowing in like 12 seconds.
Yep, perfect. This is going to be great because, yeah, I do not have a background in this. And that's why I always hear the borrow checker and borrowing and ownership. And okay, this is great.
Own string, it's under your control. You set it up. Like, essentially, you initialize the thing. And I am responsible for deletion. A borrowed type means that responsibility for cleaning up, like deletion, lives somewhere else. So imagine, we're setting up a database and I have, students and professors, right? Because we're setting up a university booking system for rooms or something. That's we have some students, right, in classrooms. Now, and classrooms can hold references to students, let's say, right? And what we don't want to do is delete the classrooms while there are sort of students present. We kind of don't want to create orphans. The type system won't allow you to create orphaned data, essentially. Every single reference that you have, which means that if I refer back to the string, which is my name, and I didn't create the string initially, I can't try and delete it because it still might be accessed somewhere else. Rust will guarantee that name will persist for as long as it needs to live for the entire program, for across threads at compile time. So you actually get some really nice properties from that. There is no null in Rust. You can't have a null pointer exception if you've ever used Java, or and like, things can't be undefined. It just doesn't exist in the language. And I know that there are going to be people who are listening here. It's like screaming at their, they're going to be waving at the ear saying, no, Tim, you're cheating. What about unsafe? And
We're going to talk about unsafe. Yep.
yeah,
Okay,
yeah.
good.
But it's like, yes, you're technically correct. And unsafe is a thing. But let's not scare people right at the start.
Right away. Yeah. Say like, generally this is the rule. And, when you're in level 12, then you can learn about the exceptions. But
yeah. Once we're like a level 12 developer, right now we're like, and we're going to make our way up to, I don't know. It's been a long time since I've played role-playing games. Like,
so if I have a borrowed string or something like that, I can't delete it. Can I manipulate it? Can I change the string, or is it purely like a read-only type of situation?
You're allowed to change the thing if you ask politely.
Nice, okay.
So Rust has another part of analysis that it does. It says, okay, you can I have some string, and there are multiple parts of the program that want to access and read from the string. Well, you can have as many readers as you want, programmer Tim. But if you need one of them to have write access, well, the situation changes. You can either have sharing, and you can have multiple readers, but you're only allowed one writer. It's like you have one or the other. If you need both, like you actually need to be able to provide a write and read access to multiple places at the same time, then you start to get into the territory of wrapping your types in things that contain locks. And I'm going to say something which has the risk of alienating a lot of people, but I'm hopeful it's actually going to demonstrate that that Rust's approach is really unified. So the same mechanisms around managing ownership and deletion, which occurs implicitly, by the way. One of the things we haven't talked about is that once your string that you own leaves scope, it's deleted automatically.
Okay, so I don't have to do like completely manual sort of memory management.
No, you don't. You're not completely manually in fact, that process of what the Rust term is dropping, but essentially we can just call deletion or cleanup, is ubiquitous. So your locks don't have an unlock method. Instead, when they get to when the thing that has acquired access reaches the end of its scope, the lock is automatically released. This means that you are freed from the possibility that you're going to incur deadlocks because you've attempted to unlock a lock twice, or weird things can happen with locking. And for example, there's no close method on a file. Like the Rust's file type doesn't have close on it. Network sockets don't have close. The ownership system is pervasive. And once you get it, it actually simplifies a lot, because the API surface for all of these types is shrunk. Like it reduces because we only need to learn one concept. Now, the problem is that this concept of ownership is pretty foreign it's not often baked into the programming language. It's baked into the way that you develop your software. It's very, very important that you think about, if you are in like C or C++ land, and even if you're in Ruby or JavaScript or TypeScript or what have you, you still only want to delete things in one place and have one canonical location where the responsibility for cleaning up exists, because you don't want to introduce null pointers, you don't want to introduce null or undefined. It's really, really pernicious. It's a really horrible problem, because as soon as you have undefined, it's like, well, where the heck, like what do I do now? Like you kind of can't backtrack from that.
I mean, so you're saying like ownership is kind of unique to Rust. Like how, I guess if I'm coming from C or C++, is that a pretty easy jump to make to actually like understand how that works? Or is that like that's a conceptual leap for a lot of people?
So C++ is definitely closer. The But see, the terminology is actually older than Rust. So the C++ community will say things like shared pointer and unique pointer, and this is exactly the same as Rust's shared, what I call read-only borrows versus read-write borrows, which would be unique pointer. Another terminology would be mutable pointer, mutable borrow in Rust. Anyway, so those map really well together, and ownership also is a concept that exists. And the other concept that people talk about is object lifetimes. And Rust just bakes it into the programming language itself and essentially requires that you give a shit. Like Rust is really pedantic and is quite bureaucratic and quite fussy. But it does it in a it's doing the it's kind of like a very strict teacher that you have a lot of respect for, like a coach. And the people that have, there are sort of multiple classes of people that have difficulty with Rust, and one class of programmer is someone who was a very proficient C developer who just was throwing pointers around and essentially, or someone who might have programmed in assembly or at some stage, because they're doing very low level stuff and just wanted the absolute freedom to kind of play with the machine and kind of understood inherently what was going on. Then they get told by Rust, actually, no, what you're doing is unsafe. I'm not going to permit you to do this. You need to actually comply with the rules of the language.
Yeah. So what are object lifelines in that sort of sense?
Okay, so an object lifetime is the span of time of the program where it is valid to refer to. So let's say that I have initialized a string Alex. The Alex string is, I initialize Alex at time 1, or T1. And the scope of Alex is it kind of exists for let's say 20 lines of the program, but that might be T6 in some logical clock. Now between 1 and 6, it's okay to refer for other parts of the program to access you. But as soon as we hit T7, I can't actually access you in a way that is legitimate, that complies with Rust's rules. And I've been talking a lot about how this is bound to scope. But that's a bit of a lie. There are other ways which you can reduce the lifetime. For example, you could, or at least pass ownership to something else. So if I give ownership, I give Alex to some function. So I pass by value. Instead of passing a reference to the original string, I actually give the string itself into some function. Then it's invalid to refer back to the original variable, even though it exists, in the original scope. Let's say I've got main, I initialize Alex, and then sometime later I have some function, I've passed Alex into that inner function, and within main later on, I then try and capitalize Alex. Now that won't work with Rust. Rust says, hey, Tim, you've actually passed ownership here. You don't get to hold on to it now. Sorry, that opportunity has passed. And if you want to write if anyone has written Go, I don't mean to jump on Go. Honestly, it's just easy. Sorry. And if I send something down a channel, so essentially I pass it, or in fact, I could do with most programming languages, I can spawn a thread and pass pass the data into that like child thread. But then I still have access to it in the main thread. It's like I can go, ha ha. Rust will not allow you to do that. The type system itself will protect you. Oh, not the type system, sorry. The borrow system. It's like essentially like a logical analyzer inside the program. You could think of it as a super powerful linter for your code.
Gotcha. So in that case, if you did want to sort of like, manipulate that value in some way, you would make a copy of it, but sort of realize, hey, this is a different thing now. Whatever I passed into that inner function, that is sort of gone. They got it at T whatever, T6, and now at T7, I can change it, but other functions not going to have access to it. I just have to realize that's a new variable now, essentially.
Right. So we actually need to decide what we want. We could decide, what I actually think the best thing to do now would be to create a copy. Alternatively, I could say, no, I only want one copy. But what I'm going to do is wrap it in some special thing. And the specifics of like what it's called don't really matter. But I can wrap the original string in some type, which makes both sides of the, both the inner function and the outer, think that they have ownership. Or I could change my inner function to accept a reference to the original. Maybe I don't need to pass ownership all the way in. Rust will force you to choose. That is why it's hard. It's not Rust being difficult. It's that computing is difficult, and Rust makes you like think about it. At least this is my. Again, I'm slightly biased now because I'm no longer a beginner, right? Like I wrote a book on the language, essentially to teach myself Rust, actually. So
the best way to learn is like to write a book about it, right? It's true. Yeah.
Yeah. I even told the publisher, I was like, look, I'm not the world's best Rust programmer. That's why and they were like, no, but you're a good person, Tim. So I'm sure you'll write a nice book. And so Rust is fascinating because we have this really interesting, instead of a dynamic to break down, that Rust is difficult to learn. And the other dynamic that is, I think, quite important for the Rust community to figure out is a perception that Rust is A, difficult to hire for, and B, difficult to get a job in. And it's extremely odd to me that these dynamics all exist when the facts are that Rust continues to grow. Rust is the only other non-C language to be introduced into the Linux kernel. It's being introduced into the Windows kernel as well. Like, that's how successful this thing is. It will dominate. It will come increasingly to grow for the next, let's say, 3 to 5 decades of software. I mean, that's in some sense a preposterous statement, but the longevity of these systems, like operating system kernels that exist, like Linux is not going to go around it's not going to be replaced in the next couple of decades. Like, it runs on everyone's servers. Like, everyone deploys to Linux. And it might change itself and morph into something else, but I don't think that something is going. I mean, who knows?
Are you seeing a shift in a shift or a growth in sort of where Rust is being used? I know you're saying early on, sort of, used for Firefox or whatever, and a lot of like sort of low level kernel type stuff. Are you seeing that expand into? I mean, it seems like we see a lot of like new infrastructure databasey type stuff written in Rust, but are you also seeing like web APIs and things like people doing that in Rust, or is that still like, hey, let's keep that in Java, Go, or Python, JavaScript, something like that?
I tried to say 4 sentences at the same time. It didn't quite come out my mouth. I have seen a massive shift over the last couple of years where Rust has refused to stay in its lane. Rust has continued to be the property, the benefits that accrue around the reduction in the number of errors that you create. Like Rust enables, let's say, ordinary programmers like myself to write extremely high performance code that runs extremely efficiently. And just like it's very difficult to express how much nicer it is to have a system that just uses like 50 megs of RAM. And it just sits there and it does its job. And you can pretty much forget it. And it is serving tens of thousands of requests a second. And it costs like dollars a month to run. You don't need a cluster. You don't you could if you wanted to. You can deploy it however you like, but you don't need a 32 gig instance and like a backup instance. And it doesn't cost hundreds of dollars. You're not constantly babysitting this thing. And before I started my own business, I actually worked at AWS, and I'm on record at saying that the reason why I have a job is I want to save this company hundreds of millions of dollars a year. And Amazon spends a ridiculous amount of money on memory. Like it's quite expensive to run AWS actually, and therefore, so just generally, Rust has been able to do very, very well at the traditional systems programming language. But I definitely feel as though it has outgrown systems programming. There are still spaces that I think that it isn't well suited to, primarily with what I would call like interactive workflows. So there's two domains that I'm really interested in that I still find Rust really clumsy for. One would be, I don't know if you've ever used any sort of data science tools, but there's the Jupyter Notebook Python kind of environment is very ubiquitous, kind of this interactive, immediate, exploratory modality where you have some data set and you're generating plots or you're kind of like crafting models. That sort of thing does not lend itself well to a compiled language that is very fussy. The other one would be kind of similar but different. I'm really into generative art and processing, like P5.js, for example, is just a dream to work with in the browser. It's just, and like, there's just this immediacy that is available to someone that is you doing front end that just is not present in Rust. And essentially, it feels as though the code is having an immediate impact on like what you're producing. And that's one of the real benefits of, I think, front-end development, because you can kind of see the changes. It's like if you're tinkering with something, it just immediately pops up. And Rust approaches that. And so a lot of the front-end, so there are front-end frameworks written in, so you can write front-end in Rust because Rust has very good support for compiling to WebAssembly. And so there are front-end frameworks that expect people to write Rust. and that works. And it approaches interactivity because of the essentially incremental compilation. We can do a bunch of trickery to essentially make it faster, but it's still not fluid. At least that's not how it feels to me. And but yeah, to answer your question, yeah, those 4 sentences, it's absolutely the case that Rust is bigger than systems programming. Like it's more than just databases. One of the other things you mentioned very, very briefly, like, is that Rust is being increasingly well used for tooling to support other languages. So, for example, like the rough linter in Python, and they have that same team is like there are a bunch of Rust developers making Python faster, and they've got this new tool which is significantly faster than pip called UV, and in the there are a bunch of
I think of like Tailwind, CSS. I think they've got some sort of tool that, strips out all the unused styles and stuff like that, outputs you something. They rewrote that in Rust in the last year or two. So yeah, you're seeing a lot of tooling around. Like you're saying, other languages basically, but written in Rust to make that go faster.
And I really like that idea that Rust can kind of play well with others. Because it's just a programming language. Like no one, it needs to prove its worth. Like it's literally just a programming language. Like it's not special. We shouldn't, like, it's a cultural artifact. It's kind of but it's not precious in the same way that I would say there are other things that humanity produces that I think are much more important. Just in terms of that CLI story, one reason why Rust does very, very well, especially compared to tooling written in dynamic languages, let's say like a Node or Ruby or old stuff is even written in Perl, is that Rust allows you to kind of like pack up all of your dependencies and all of your code and compile that into a single binary. This was very prominently. It's not the only language that does this. Go, for example, was also very famous in that it had this opinionated style where you could just create like a single file that you could put on any computer and it would just work. Now, Rust offers that same workflow that you can compile something on your laptop and then it can just be like copied to wherever you want and it will work. There's no installation step. You don't need to worry to the same you don't need to worry nearly to the same extent about like do we have the right dependencies installed? Do I need to like ship like the programming language? Do I need which version of Ruby do I use? Do I have all of the gems? Like all like, are they compatible? Have I got the native version? Like, did I have the right C compiler so that I could compile the C native extensions? And, that kind of stuff doesn't exist in Rust. And so it's very, very good if you are writing tools for developers because all of that packaging nonsense vanishes.
Yeah. You've mentioned Go a few times, sort of in comparison. Do you see a lot of sort of like, things that were being written in Go? I know Go was a hot language and still is used for a lot of different things. Do you see that shifting to Rust, or are they different enough where it's like, hey, if you sort of made your piece with a GC or something like that, maybe you're just using Go? Like, do you see shifts happening there, or are they fairly distinct?
So Rust was like a bit of a answer your question. I see, and my perception is in the wrong place. Like I see more shifts of big things. So, for example, sidecars would inside the Kubernetes world would be, it's easier to write them in Rust. Discord moved its backend from Go to Rust because of the garbage collection pressure. There's a really fascinating blog post where they say, every 2 seconds, our latencies just have this really horrific spike. Like, what's up with that? And it turns out that Go said, whoa, I need to actually free up some RAM. Like, I need to reserve some time myself to kind of get my bookkeeping done. Otherwise, and that really impacted Discord's ability to serve messages consistently. But the reason why I the reason why I compare Rust to Go so frequently is just that they are, there's 2 reasons. One is that historically they were seen as kind of frenemies, or at least they were kind of like, one was developed by Google and the other was developed by Mozilla. So this is kind of like the historical origin stories. They sort of appeared in the public eye at around about the same time. And this is about 2012, 2013-ish. And then it looked like Go was just rocketing. And Rust was slow. Like, it took a long time to get any sort of real adoption. And at that time they looked extremely similar. Go's has Go routines. Rust had these little similar things, which I think would probably be called green threads or fibers, depending on your or like Erlang processes if you're from the Erlang space, and had this. They looked almost identical in terms of the way they wanted to like see the world, but eventually. And so they were kind of spiritual. They were compared very frequently together. Now, the reason why I talk about Go so frequently now is that Rust and Go are very divergent in their philosophy. And so even though they both provide very, very high performance and look superficially like they probably fit in the same areas, they are very different. Rust is very focused on being technically correct. It's not going to allow you to send maps down a channel and then access them. Like once you've given something down a channel, like that's it. You cannot, like you've given it to the channel. You can't hold on to that data anymore. And likewise, so there's just a whole bunch of like design philosophies. Rust is a large language with a relatively small standard library. Go is a very small language with a very rich standard library. And so even though they play in the same area with like Kubernetes is probably the most famous Go project. And yeah, was like hugely successful. It has a significantly different philosophy than Rust. And I think that I don't want to criticize anyone for programming in the language that they prefer. But I think for large programs that exist for a long time, where you want reliability, where you want to be able to protect your users against like memory safety, like memory leaks, and your own system against memory leaks, and your users against like safety bugs and like crashes from null pointers. And so you want system stability. Then Rust is like a very strong contender. Should it be the language that you use to write your next big thing? Well, maybe not. But I think it should be on the list of things that you consider. Like I think it's earned its place in that list. Because there are a bunch of considerations. Like, do we have enough people who know Rust? And that come into play when teams start deciding on programming languages.
You mentioned the standard library, the smaller standard library of Rust. And I don't know if you saw Phil Eaton wrote a blog post about this last week, I think, just comparing Zig, Go, and Rust, I believe, and on a few different axes. And one was around that standard library. And he said he wished Rust had a bigger standard library because he thinks it just leads to a little bit of, third-party package sprawl and some issues that way. Do you like the small standard library? How do you sort of come down on that?
I don't like the small standard library. I think that it's too. It comes like I know I've got some suspicions as to why it exists, and it's showing Rust's heritage as the systems programming language, and compared to its peer there, which would be C, Rust is a very rich standard library. C's standard like the C standard library is extremely austere. Like it's very minimal, like minimalistic compared to what we might see from like a batteries included approach. And so compared to that, Rust is quite rich. Like it gives you a lot. We have things like hash maps for free. Well, not quite. But now I haven't actually read the post, but I think this is a really interesting discussion because it's a thorn in the side of Rust. It's like, well, we'll just allow the community, like this, essentially copping out. Like the standard library maintainers say, we don't want to expand the library because we don't want to crush essentially innovation. We don't want to pick winners, But that has a very significant cost to people that are just starting out. And because what am I going to do? Are you seriously expecting me to search through tens of thousands of packages to find exactly the right thing? It's like, why are regular expressions not in the language? Like, why? Like, and there are other it's like, well, how do I represent, I don't know, a web request or JSON? Like, what the heck?
Yeah.
and essentially, I think what the Rust, and this isn't actually the language problem, but the community has this thing where they're trying to abstain, and they're taking. This is where I come into tension with, I think it's with the Rust project, really, because I'm not part of an official Rust team, and so I have played with this. I've joined a couple of meetings for the standard library, so I was like playing with the idea, but ultimately it's quite a lot of time, and I'm in the wrong time zone. I'm based in New Zealand of all places, and so I can't really hang out with people in Europe. Anyway, there's a philosophy there where the standard library maintainers are saying, hey, no. We need to give space. We kind of need to give oxygen. It's like, well, now, Rust is pretty old now.
Yeah.
Like it's we should put regular expressions in the standard library. Like, are you seriously going to suggest that, I understand why there's concern. It's like, we don't want things because the standard library is where like code goes to die. That's one of the problems. It's like no one wants to maintain something that essentially can never change. Once you introduce it into the standard library, you can't really touch any of the APIs because suddenly you don't want to destroy people's code. But like, isn't that a backwards? Isn't that like in like really odd for the philosophy? Because if you're in the standard library and you're maintaining some code that is used by, let's say, tens of millions of projects, it's like, is it really a failure that you can't upgrade, like you can't break backwards compatibility? Like, why is that actually a problem? Like, that's fine. It's boring. And so the problem is there's a whole bunch of like human people don't like working on maintenance. People really like building new things. Complying with the standard library means you suddenly need to introduce a whole bunch of like political stuff, which you don't really want to do. You have to sit in committee meetings and things like this. Becomes really dull if you're a open source maintainer. It's kind of like not what you signed up for as an open source maintainer. But at some point, there's going to need to be something which says for multiple reasons, but there's going to need to like some subset, let's say like 50 packages. And we talked about regular expressions a couple, but there are others as well, like deserializing JSON or like shuttling data around. And there will be like some set. In fact, I have a pretty good idea of like a couple dozen packages, which essentially, if you think of like a solar system of the core exists, and then the standard library sits outside of the core, and then you might have something sort of in orbit of the planet that stretched analogy, apologies, but we have some kind of blessed set of third-party packages, which just makes it a little bit easier for people in their first 3 days with Rust. Because the real issue that I have with like design by committee, or at least design by talking to current Rust users, is that the Rust users of today are actually in a significant minority of Rust users in tomorrow. Like one of the things, and like the people that are just starting today, like there are many people who are 14 and are like learning, like they're watching YouTube and they're thinking, hey man, I should learn to code. And what we're doing is adding barriers to those, there are a whole bunch of people for whatever reason. It's like, I want to learn Rust. Well, I don't want to learn Rust, and I don't want to have to learn Rust and all of the searching through packages. It's like, I don't know enough to make an educated guess. And so this is a struggle that every single programming language community faces. But Rust now because it is essentially at the center of so much software infrastructure, I think it needs to grow up a little bit. It needs to kind of like accept that it is going to like it's going to be used for serious, boring projects. It's going to go into trains. It's going to go into planes. It's going to go into missiles. Like this,
space shuttles, anything.
Yeah, like it's then the kinds of demands that an aerospace company has from a programming language are different than the demands that fun and kind of quirky, like upstart startups have. And somehow we all need to be able to work together. And so I don't think this would, and I don't know. Like, I'm sure that there are plenty of people that are like, you know what, Tim, Rust is fine.
Yeah. Yeah. That's the hard part, right? How do you figure out like, where it needs improving and, especially like you're saying, the people that know it already, like they have a little bit of status quo bias, or they understand it, they know how to work with it. And how do you adopt it to the needs of the next generation? On that same note, like I have a few, like, I want to call them like issues with Rust, or like things I hear about Rust. And I would say small standard library is one. Another one is unsafe, which you referenced earlier. Like, hey, Rust has all these incredible like memory safety properties and things like that. But then you have this unsafe keyword. You can sort of escape out of it. People say, hey, I look at a Rust package and it's got unsafe everywhere. What am I doing here? I mean, how big of a problem is sort of Rust unsafe? How do you sort of think about using it judiciously or advocate it in your training? Like, what do you think about unsafe?
Yeah, right. So just to give a very, very small plug for my book, actually, not meaning to like be too...
No, yeah, absolutely. Plug the book. Yeah, it's a great book.
Yeah, so. Cool. So one of the things that Rust in Action actually does is give you a run through of unsafe, and we actually try to use it. And essentially we can do things like get a floating point number and like unpack it and like inspect its bits and like play with it and kind of like, so, but then like, and also to demystify this thing, it sounds like extremely scary. It's like I'm putting on the hazmat suit and I'm going to go into contaminated environment. It's like it's radioactive in here or something. It's like I'm going into a hospital. And the interesting thing about unsafe code is that we should actually like explain a tiny bit of context. Rust has a keyword, unsafe, which marks a block as what? And that's what we're going to explain now. That essentially Rust has this ability to kind of, and what's been hinted at is that essentially it gets to turn off a couple of the dials. But it's actually unclear when you're starting, like what those dials actually are or how powerful they are, because there's this inherent fear that we're going to do it wrong. Okay, so let me talk about what those dials are and how serious it is and why unsafety, or like why it's as... Yeah, let's actually start there and we'll see what other things pop up in the conversation. Unsafe does not allow you to do whatever you want with the programming language. It actually relaxes very few rules. What it is doing is pushing the burden for upholding Rust's rules from the compiler to you. So imagine I have some third-party library that is responsible, like gzip. So I have libgzip in my code, and it's a C API. It's written in C. And I really want to compress some data because, I'm sending data across the wire. And so what I do is I allocate some memory, have my string, or have my text, and then I give gzip a pointer. So a pointer is a reference to some span of bytes, and I say, look, for the next 4 kilobytes, that's yours, gzip. Please do your best. like shrinking this for me. And then Jesus says, okay, yeah, like I'm good with that. Okay, I'm going to give you back. Oh, so we're giving Jesus probably a pointer and a length, saying, well, that span of so at that location is some sequence of bytes up to, and we've got the 4 kilobytes in length, and all of that is yours. I won't touch it. You promise not to touch it because you're giving it to Jesus. And Jesus says, okay, cool. I can do this. I know about compression. Okay, so I'm going to give you back another length. And it might be in the place, it might not be. And your code gets back another pointer and gets another length. Because Jesus has said, aha, so I decided to actually create a copy because I didn't trust you. I thought that you might touch it, so I had to be safe, and I decided to give myself another copy. I've given you back another span of bytes. Now, it's shorter. You need to figure out how to incorporate those bytes in your program. And so Rust's borrow checker cannot interrogate what the library is doing. So you, the programmer, need to do its work for it. So you have to manually construct Rust's string type, for example, and comply with any of the technical term is invariance, or you need to guarantee that the preconditions have been satisfied. For example, you need to guarantee that the pointer is not address 0. So the memory address 0 is otherwise known as a null pointer. And if you try to access that RAM, your program will crash. It's just an integer. So that's the crazy thing about memory addresses and pointers. Everything, all of this abstraction about like references and all of this terminology all boils away. It's just an integer. And but that's all you've got. And so unsafe is sort of a bridge between Rust's very high-level abstractions and the computer's very primitive data types. If you've ever coded in assembly, I've done it very rarely, although I've done, like written a CPU emulator and stuff. And you discover that there's really only two the data. Your computer really only understands like 2 or 3 data types: a memory address and like data. Like it just has bytes. Like that's all it's got, and like might even just be integers. Like that's not a very rich type system, and everything else has been added by programming languages, kind of over the top. And unsafe pushes responsibility for deletion to you as the programmer, and also that exclusive access is provided in the right places. So you can do things with unsafe, like take some random integer and then tell the computer that it's actually a memory address. So we can actually change the type. Or I could do things like I can essentially lie to the type system and say, aha, I've got from the network, I received 4 bytes. Now, the network protocol specifies that those 4 bytes actually represent an integer. Now, the type system initially gives you back something that looks a little bit like an array, which we'll call a slice, and each of single bytes. And you, with unsafe, can kind of flip that around and say, aha, no, that's actually a 4-byte integer. And these are the kind of things that are unlocked with unsafe. Now, the question is like, well, that doesn't seem super dangerous. Sadly, it's horrifically dangerous. So people are much worse at this form of analysis than they think they are. Like historically, like the evidence continue, like we are still people and we are fallible. Like essentially we're bad at it. And so so there's some other tooling that will run your tests and actually trace the memory through the unsafe blocks. So essentially you've got your compression library and essentially, and it will check. Like, did you follow the rules? It's like, oh, no, sorry. You broke the rules. And it's surprisingly embarrassing. It's like, well, heck. Because sometimes it's really, really hard to, like, in simple, like, and the most annoying thing is it seems like it should be trivial. But the evidence suggests that the smartest programmers in the world are not smart enough to figure this out. Like, that has been proven so many times. And it's like the software industry. And so there is this kind of a community. Like, there's the kind of the immune system of Rust. Like we talked about there's kind of like the third-party ecosystem is pretty vast now. We've got over 100,000 packages there, and there's plenty of unsafe. In fact, and I did some analysis for a talk that I'm going to give next week, actually, at Rust Nation UK, called "Unpacking Unsafe." And about 5% of packages, I think, I'm getting the numbers wrong, have some unsafe block. And the problem is that not all packages are distributed equally. Some are more important than others. And these more fundamental things are actually, they require unsafe. But famously, people are kind of allergic, or at least very skeptical of claims that unsafe is fine. So people laugh at Rust. And just for like this particular counterexample. So they'll say, aha, but in Computer Science 102, I was asked to implement a doubly linked list in C. So this is a data structure where every element in the list refers back to the thing that follows it and the thing that preceded it. This is a data structure which is impossible to write in safe Rust, at least without incurring runtime cost. It turns out that it's actually really, really challenging to write in C as well properly. It's actually like extra, but you can't do this without unsafe blocks. And the thing is that the Rust community is kind of allergic to this construct. At least it places a very high degree of the burden of analysis on this being like an acceptable practice. Because there are some people that come from C++ or from some systems language and think, aha, I could just unlock the gates. It's like
and they get into trouble.
That's right. Oh, this will be fine. This is exactly. And then you just incur the costs. All you're doing is incurring the costs that you tried to get freed from. It's like you're essentially removing the benefits of Rust, but maintaining some of its challenges. The Rust community sorry, I don't mean to. There was just one other point. I was a little bit disappointed with the Rust community's treatment of a particular web framework. So I don't know if this is like the annals of history or something, but there was a big sort of a blindingly fast web framework called Actix. Actix, ACTIX. And this was just knocking benchmarks, just like off the charts. And it used unsafe. Like there was some data structure or something that essentially it's like, no, if we I actually don't know the internals, but it was the maintainer just got a huge amount of vitriol. Like people just jumped on the guy. He ended up saying, you know what? I'm out.
Done with it. Yeah. Interesting. So is that framework like gone? Like, has it sort of faded away now? Or?
Yeah. So the history is really interesting if you care about these things, and like I do from like an open source maintainership kind of point of view, because you're like, well, it's like, I don't think that we should essentially like jump on people that make mistakes, even if you think that they are genuine mistakes. I think it was a little like, my recollection is kind of getting a bit fuzzy, but I think there was like, how dare you tell me that I'm doing the wrong thing? I think that was part of the issue, where someone was like, actually, no, I made this choice and I'm right. It turned out that the uses of unsafe were actually unsound. Like, it could actually introduce memory unsafety. Like, the criticism was correct from a technical standpoint. And what has happened is that Actix has been replaced by another framework with its same name, by its same, it's kind of actually, it morphed into something else. So Actix, the original implementation, was an actor-based system. This idea that you could write little tiny functions that would run independently of each other. And the actor framework was using this unsafe stuff to kind of make sure that everything was as fast as possible. And the web framework carried on, but essentially they ripped the guts out of it and like replaced the backend with what in the Rust community is pretty well known, this thing called the Tokyo ecosystem. And so essentially what is now called Actix Web is a web framework like at the same domain name by new maintainers,
but just a totally different architecture, totally different setup.
Yeah, like completely different, except for the fact that there is like one little thing, which is the WebSockets implementation for sort of, I don't know, technical or legacy reasons, I'm not sure, still uses like the original actor framework, and presumably that will also, but it's not HTTP based, which is why WebSockets probably a little bit complicated. Anyway, so there is like there is kind of like there's one legacy bit, oh no, I say legacy, one little bit left of the original stuff, which itself has actually been totally revamped to use significantly less. So anyway, I think culturally unsafe is probably more scary than it needs to be. I think it should be essentially de-risked.
So if I'm wanting to like look at a package, you mentioned there's like some tooling to do like some analysis of my code and look at the memory and things like that. Can I have pretty good confidence that, hey, if I'm looking at a third-party package, it's using some unsafe, that it is being safe? Or is it really just like going to take some people vetting it, looking through it, using a lot in production, getting some bugs out of there, and then figuring it out? Or like how if, you know, if I'm a new developer and I'm looking at third-party packages, how do I get some sort of just confidence in what I'm using there if it is using unsafe?
If you want to do the analysis yourself, so I'm going to start with like a multi-layered approach. Like, obviously we can't get to perfection. Like, this is a standard that we cannot obtain. You can have a policy of saying that we're not going to allow unsafe code. You know, like it's like we're writing a web API or we're writing something and we actually really don't want unsafe. There are you read the docs and it's like there are lots of things that, like, there are statements that some libraries will make. It's like we don't use unsafe here. So that's one layer. There is a community auditing system, and I'm just like looking it up now. So all of the Rust ecosystem essentially is kind of anchored with a command line tool called Cargo, and there is a little bit of and it just like Git subcommands are just other executables that are named the right way. The Cargo ecosystem has other subcommands, and there are two. One is called cargo-audit, and this provides security notifications and so forth when CVEs for Rust packages are developed. And the other one is Cargo Vet, which provides the ability for people to endorse specific versions of third-party libraries. And at this, if you're a small business, like if you're a small team, that's probably the level of assurance that you want. if you are like at a bigger scale, like if you are 10,000 developers or more and you want to have like a secure, like a very secure tool chain, like that's a slightly different scale. You do things like mirroring, you create a mirror of all of the public packages and essentially allow list like specific versions as they pass through gates. And that's actually quite doable with the tooling. So if you want to run your own mirror, you can do so. It's actually pretty easy. And you can apply policy filters like, it's like we don't want to allow GPL code in our system. That means that you could do that if you want. Or you could even write a scanner which says, hey, do they use unsafe here? I wonder if actually you could, I don't know. I'm opening myself up for a lot of criticism once I don't do this, but I'm going to sort of say one of the things that I could do. I have I've got an unsafe code research project called Heat Shield, and at the moment there isn't a lot of like action on the repository now. I'm looking now at the commit. I haven't actually pushed things up to GitHub in a long time, but Heat Shield provides the ability for you to at least like scan for unsafe and just kind of like give you there's another one as well which is called Cargo Geiger. So there's a bunch of like little tools. This Heat Shield thing is designed to be able to provide an analysis of the entire ecosystem. So it's trying to be run against every single public crate to gather a sense of like, well, what if your dependency is vulnerable or gets taken over, or like maintainership changes to someone who decides to like leak secrets. I think the software supply chain story is fairly. It's been well discussed, but I mean that's sort of part of this discussion as well.
I want to talk about Amazon to AWS because you mentioned like places with 10,000 developers, and you were at AWS, you had a goal of saving them hundreds of millions of dollars. What did that sort of look like? What was your time there like? Like what kind of projects did you work on? What's the desire within AWS, or was it Amazon as a whole, or was it AWS specifically? And like what's the desire to be moving stuff to Rust? Is it porting old stuff? Is it writing new stuff? Like what's that? Yeah.
Okay, so I can talk about things as they were about a year ago, right? So my role, in fact, our whole team suffered from we made it through to the third round of layoffs in 2023, essentially. So inside Amazon, there is one group that has responsibility for developer tooling across all of Amazon. So this is AWS, Amazon, a couple of, and its subsidiaries as well, like Twitch, for example. And this includes its build system. So Rust has a proprietary build system that is weirdly not talked about anywhere. And so sadly, I can't really reveal any details except for the fact that it controls your entire build. So you describe like for every single commit, Amazon essentially knows the entire provenance of all lines of code, which enables it to do things that are really amazing, like hot patch every single production server, pretty much instant, give or take like some pretty significant, like there's some caveats there that are pretty serious, but in principle, it's a very, very good system. Although it's showing its age, it was originally developed in the late 90s. Anyway, my job was originally to support Rust build. So this was to support the mirror of crates.io, as well as other projects that we discussed about, having things like an internal playground so that we weren't leaking proprietary code like to the public playground, and bits and bunch of pieces like that. And then eventually teams like some of the projects that have been like it's public knowledge that S3, for example, is looking really heavily to Rust. EC2 has components. There are actually multiple very large service teams. So when we talk of Amazon or AWS or any of these large companies, once you get behind the curtain, it becomes very obvious that it's not really one company anymore. Any of these large services, in particular Amazon, because there's a very strong philosophy that each team chooses its own tools, and its own training and a whole bunch of other stuff. The Amazon way is that Amazonians is what they call themselves, are strong owners, and individual teams are the best place to make decisions about the tools that the team should be used, with the exception of things like security and build. So this is a very privileged position, centralized inside the entire company, including Amazon.com. So it's a team inside physically housed in AWS, although it predates AWS existing. So it was originally part of Amazon, and hugely fundamental with the other. And they took a strategic bet on Rust. They're like, we're going to stand up a team in 2022. We're going to hire some of the world's largest, most prominent Rust stations, like myself. John Genset was already working there, but he got them to agree to bring me on, as well as Luca Palmieri and several others who are less prominent, but probably more competent, actually. So we had about a dozen of us building some pretty neat stuff, including so my role eventually morphed into much more of an education focus, because lots of teams started looking at us. And so I wrote a doc, which you do because you're at Amazon, you write a 6-page doc and say, hey, we should be the world's best place to write Rust. That means that we should support builders so Amazon, inside Amazon, you're a builder, you're not a developer. We should support builders wherever they're at, and we should be able to teach them Rust. And we should have an education program that draws in expertise from across the company about building services at scale. So we're not teaching the language per se. We're saying that if you want to serve traffic to 1 billion people or more, or if you want to create a service that has single millisecond response times, and you want to do that at ridiculous scale, then we need to teach our teams that. Because one of the downsides about Amazon, at least this is my sort of experience, is that AWS and Amazon have this issue where they need to be pretty careful with how I express this. It's really a common story is that people, they can just chew through lots of enthusiasm from relatively junior developers, let's say fresh out of college. They get a job at a FAANG company, and then they essentially are just thrown away when it's a meat grinder. At least that's how it feels. And especially at the junior levels, once you, I entered Amazon as a senior engineer. And so I was essentially not exposed to that mentality. I had a wonderful time. No one speaks at reInvent in their first year, but I got invited to speak at reInvent. I was a bit of a rock star inside that company. And so I was in a very privileged position, but most people are not. And most people let's say they're fresh out of college are not. And there is, and I think but I think that Rust at scale, or Rust at these large companies is really strong, but the enthusiasm for spending millions of dollars a year, because essentially that's what a team costs. If you want to have a dozen engineers there, you're looking at $5 million investment or something, probably more. The enthusiasm at like a senior management level starts to decrease very rapidly if you're under pressure. Now, I don't know what the situation would be like internally. In the last 12 months, the share price is like rapid, like so kind of like tick, and like it's gone nuts. The profitability of the has gone through the through the ceiling. Sorry, not through the floor. And my personal belief is that they made a very short-sighted decision about getting rid of our team. I get really angry about it whenever I think about it in depth. I think that they had an opportunity to essentially demonstrate leadership in probably the most impactful programming language that is going to exist in the next couple decades. And I should say they still have a Rust team. So they had two. They had a Rust team. For example, Nico Matsakis is lead of or co-lead, I think, of the language team, and they have, and so the people working on the compiler, like Esteban, Kuba, and Felix Koch, he is lead of the compiler team, are extremely senior people inside of AWS and inside the Rust community, and they are very, very impactful in what they do.
Are they like contributing back to Rust? Or are they building internal tooling for AWS? Or
they are doing I can't speak about what they're doing internally. Like I'm not really privy to that. But presumably there's some mix. But they are definitely very active inside the Rust community at large, developing the language. There is for example, Carl Lurch, the lead maintainer of Tokyo, is an AWS employee. And so AWS essentially is funding the development of Tokyo and lots of the Rust compiler itself. And the idea that you're going to have a team focused on internal tooling or direct, and in addition to that, was like a very heavy lift because of reorg and stuff. It turned out that these were both of these teams ended up being under like the same part of the org chart. And so at some level, it was just like, what the heck? I've got two Rust teams. They're both extremely expensive, and they're not generating me any revenue because they're not service teams in the traditional sense. Like, so like from like the spreadsheet, we just looked redundant, and in that,
yeah, hard to align those incentives correctly. Even though I'm sure it was beneficial to AWS and Amazon as a whole, but it's not beneficial to whoever's line it went to on that chart. Yeah.
And I think that it gave me a very, like, even though my tenure there was pretty short, actually, I think but it's been one of the most instructive periods of my career, because it finally gave me the confidence of saying, like, wow, you're really good at this. Like, and one of the things that I've struggled with is that I have been like feeling like every side project sort of fails. Like essentially the book took way too long. Like it took way too long. I was working 3 or 4 nights a week plus time on the weekends for nearly 4 years. So This is like nearly 2,000 hours. Because the thing is, at Rust in Action, you like build a database and you like build a CPU emulator, or you build an NTP client. And it turns out that if you want to teach this, you actually need to implement the thing. And that took a couple of iterations. And then you need to write the chapter. And then sometimes you need to whittle down the implementation because you can't introduce two language concepts at the same time. And like the book was horrific. And and now I look at my YouTube channel and I think, look, you only have 8,000 subscribers. Like, what the hell's the point? Like there are other people that have 800,000 or whatever, and like there are, and so this confidence thing has been really has been the big shift, because now I sort of don't believe it. Like this week, I'm getting flown to England because people want to listen to me speak. That's a very strange feeling for someone who has always felt that I wasn't quite good enough. Like I did Python, data science. Like I felt like I got the book contract essentially by accident, because I was contributing on the forums and I got a random email saying, "Hey, do you want to be a co-author of a book? Because we've got one in the pipeline, but the lead author is just really overworked. And eventually they pulled out, and
And you became overworked. Yeah.
I became the sole. Yeah, that's right. So anyway, and now starting my own business and doing it profitably. And so I'm now contracting to some of these like huge companies, and essentially holding my own has been the most, it's just been the most crazy 12 months. And I think that, Rust is part of that. Like Rust is an empowering technology. Like the reason why I the reason why I care about this is because Rust is going to make a difference in the ability for the industry to create stronger, safer, more energy efficient programs. Is everything going to be written in Rust? No. But is everything that we write from now on going to be influenced by Rust? You bet. And I think that means that everything is going to be stronger, and everything is going to be more secure and more more energy efficient. And let's do better. Like as an industry, we're awful. And that is that's kind of my spiel.
Yeah, I love that. Like, I think it's so helpful to see that sort of thing, like the internal doubt and like, I'm sure people look at you and you're just like, everything. Like they look up to you, like, sort of like a god in this Rust community. You've written this book that's amazing. You've done all this stuff, and you still have like that doubt or like the disbelief of like, people want to fly me out in here and give a talk and things like that. So I think that's helpful. Like, to other people get it out there. Like 2 questions I want to ask you about your teaching and sort of what you're doing now is, number one, you mentioned how much work that book was. I'm sure Manning's like so happy with it. Like they got their money's worth out of you for sure. But like, number one, are you, even looking back at all the work it took, are you glad you did the book? And number 2, what sort of advice would you give folks that want to go in this sort of maybe like education, training, consulting, coaching type thing? Any advice you have from them that you've picked up over the last year and 5 or 6 years as well?
Writing the book has been absolutely pivotal to me being able to essentially springboard out of like the developer track into tech influencer in the good sense of the word. And that is someone like I have been able to, like, there has that book, and really actually not the book direct, although the book is nice. Like the book gives like the reason why I went with the traditional publisher rather than self-publishing was because of essentially the ISBN. Like essentially because you could say like there is some credibility behind it. And that in my case has been hugely true. I would not be speaking to you if it was not for that book. Like I would have just been some random Rust developer, probably mucking around. And even if there was some other person who like had worked at AWS before, and so what? Like, what the heck? Like, that's not interesting. Now so it was hugely instrumental, and it was awful. It was one of the most difficult things that I've ever done. It was. I don't even know how to express how close I was. I can't believe that I'm still in my relationship. At that time, at that time I gave up a lot. I gave up my health. I was very active. I used to really enjoy running and lifting. I had this goal for, I don't know what the imperial units are, but like lifting 200 kg, so I think it's 500 pounds, and like as a deadlift and running a 4-hour marathon. Like I really wanted both of those in 1 year. And I have still got that as a goal, but it's now 7 years later or something. And I also had kids, and I really wanted to prioritize that. Like I became a father, a new city, new job. But I hated just working in a job. Like I'm too outspoken. And I found myself always fighting the fact that people had this expectation for what a software developer does or what a data scientist did. So I was kind of on the software side or of data science. I would, and that people were like, oh no, you shouldn't really care about that. I was like, I really do. And one things that I really appreciate about Amazon actually is that they like people to be outspoken. In fact, they expect people to speak up. It's one of the like internal tenets that they follow. So it's one of the things I actually respected about that company a great deal. And but what my advice for someone now would be that you need to start today. And that doesn't mean start big. It means start really, really small, because your success will compound. And the compounding effect is going to be much more important than your like current velocity. So essentially, don't worry, and we're not, people are probably listening to this, don't worry about like your position in, like, let's say we're at 0 and we're going up to like expertise. Like, don't worry about where you are in that level. You will grow. What you need to worry about is your rate of increase. And the thing that is going to give you the most return is small investments regularly, and essentially allow compound. Like, it's impossible to practice regularly and do things like, and choose your space. So you don't need to be a YouTuber. You don't need to be a blogger. You don't need to do whatever you want. But the process of creating is going to be, and find, and is up to you. Like, you choose your medium. You get to choose. This is actually up to you. You should be very mindful of YouTube as a platform. And like I hate it, I gotta say, because I find myself clicking the refresh on that analytics page way too frequently. I was like, oh, YouTube is addictive as a viewer. You know what? It is way more addictive as a creator. The whole thing is gamified. It's like, oh, just one more video. And every time you publish something, doesn't matter how terrible it is, the stats go up. And and it's like, wow. And then I think, oh, I only had 1,000 views on that thing. I'm like, well, actually, if I was to give a talk, let's say at a meetup, that's like, let's say 30 people. But YouTube has this reach. And so it is actually quite nice, but be so mindful that you understand why you're there. You are there because you are sharing, because you have something to give. Do not try, you're going to, and I apologize to doing something, asking you something that's impossible, but try not to compare yourself against the people that you look up to, because you will constantly feel as though you are failing. You won't believe it when someone says, that really helped me. You'll think, I think that now. Whenever so in fact, you talked about self-doubt. Here is something absurd. Like, I'm actually surprised at myself for doing this. I had a live stream this week. So I try to stream on Sunday afternoons for those people in the state.
I watched some of it. It was great. I just like pulled up Twitter and I saw you were streaming. I'm like, I'm going to pop in and see what he's doing. You're like building a web framework. But
Oh, right. Yeah. I was like, let's. And it pops up on YouTube. And YouTube has this feature on live streams called Super Chats, where you can essentially give a tip. I've never had anyone give me a tip before. And I got this really weird notification. Someone has tipped you $100. And I was like, I didn't even say thank you because I was convinced it was a glitch. Like, I was literally like, oh, this must be some weird spam. Like, they've been able to figure out how to psych me. And that is something that I am constantly trying to convince myself. Like, the reality is that I am highly successful. The reality is that people really appreciate my approach, the fact that I intentionally make mistakes and talk people through my thought process of like essentially digging myself out of the hole. Like, that's actually part of the vibe. Like, and people like me. People trust me. I'm a very good coder. Like, I have been able to like meet the bar or exceed the bar and multiple places. And like but yet my brain has got this thing where it says
it's not enough. You're not good enough.
No, yeah, it's not. You need to build more. You need to do more. You like this, and so, and in particular with YouTube, I find it a really corrosive space for me mentally, and I wish that I could kind of like hoist myself out of it. But I like it there because at least I accept the downsides, given the fact that it's easy for people to just like find me. And there are other things that I do. For example, even though I always use a free editor that's pretty basic, like it's just a pretty stock standard VS Code with almost no extensions, because I want my streams and my material to be as accessible to people as possible. If I was to use like a crazy Vim config or like some proprietary like editor, this suddenly creates a distance between myself and my audience that I really dislike. The last thing, I mean, maybe not last, but nothing that popped in my head was that the majority of your audience as an educator are people who speak English as a foreign language. It's actually, and so be very careful with the way that you speak. So, for example, one thing I like to kind of point out to people from the Northern Hemisphere, UK, Europe and the States, and also our friends in Canada, is that I have no idea what a North Star is.
Oh, yeah. Like a North Star metric type thing that you hear, like that turn of phrase.
Yeah, it's like, that's our North Star. I heard this, they talk, because I worked at an American company, and I was like, what does that mean? Like I know what symbolically does the North Star even mean? Like, this is not something that I know. I've been trying to find, and I've heard people in where I'm from say guiding star, which is almost kind of sort of the same but different. One of the things about the North Star is that it's in the same place in the sky the whole year round, right? Like, that's why it exists. And so we know where to go. We can essentially anchor ourselves to that. But there are no stars like that in the Southern Hemisphere. So we don't really have the same ability. And like, there are some other things as well for people that are in the States. I like the due to you, by the way, if you want to focus on an American audience and own the fact that you are an American, that's absolutely fine. But there are some things that I think that people say without realizing it. And so the choice here is to be intentional about what it is that you're saying. And for example, analogies to baseball and basketball. Like, these are quite American sports. And even just before in our conversation, I talked about like university, like a students and professors. Now, where I'm from, professors actually are quite rare, because we call the rank in the university system here for what in America is known as a professor is actually called a lecturer. And so a professor is several ranks higher, and there might be one professor per department, for example. And before that, you have associate professor, senior lecturer, lecturer. So you can't escape who you are as an individual. You can't escape your culture. You kind of can't really decloak that. But the one thing that will really benefit you as you try to educate others is lots of self-reflection and understanding like what it is that has because if you are able to understand what has influenced you, you're going to be in a much more empathetic position to be able to discover like what influences others. For example, talking about cultural influences, one that's quite just like very stark would be using cars as transportation, like personal transportation. Like this is a very Western like modality, like is to be like the very first choice. And even in like a lot of Western countries, cars would not be the first choice. Denmark has 90% penetration of bicycles and only 40% penetration in automobile, like in like motor vehicles. And so if you're in Denmark and you think about going to the shops, I probably would or even going to school, I'll take the bike. And I wonder about, it's very difficult for me to see what is essentially invisible to me. And I have some really very obvious mannerisms and quirks, which I kind of like cringe at when I see recordings of myself.
People love it. Yeah. It becomes part of it. Yeah. People want to get to know you and stuff.
And that's actually absolutely right. That your audience is connecting with you. And part of you needs to figure out, like push through the doubt, push through the fear. And so there's a couple of ways that there's a couple of things to do that have helped me. One is I don't need to be prepared. I just need to act as though I'm prepared.
I can't get over that. Sorry. I can't get I have to prepare like a psycho because I'm like too nervous about not being prepared. So, but anyway, I'm excited to hear this one.
Yeah. So for example, last year I would probably spend between, I don't know, up to 100 hours per hour of like physical presentation. Like if I was to, I could find myself devoting weeks and weeks and weeks to a talk. And a lot of the time, I find myself up on stage, ad-libbing a little bit and actually relaxing, and the audience responds a lot more. It comes across as much more genuine. And so what I was saying about the preparation side is that you actually have got this. You're better prepared than you believe that you are. And the other thing about helping others is that making mistakes is part of the help. If you feel as though I worry that, so the big thing about me is like people say, oh, look, Tim is an expert Rust developer. It's like, you want to bet? I kind of can't shy away from the fact that like I suppose I am an expert Rust developer, but I still spend plenty of time interpreting compiler error messages. And part of that is inherent in the process and actually explaining, okay, well, this is actually what the compiler is saying when it generates this particular error. Well, it's like, I detect that. People want to people will respond to you being genuine and you being empathetic with them. I don't actually like entertainment as in the guise of education. So the masterclass kind of approach where you've got extremely high production, but essentially it's like
you're skipping over all the everything that can get that will go wrong as you're sort of making that development process. You're gonna run into bugs.
And like and you're changing what I like to do when I work even remotely is try to remove barriers, or at least the perception of, like, I'm trying to say that I'm trying to remove the elitism in the room, or like remove the and I say that, like, in a group of 12 of us, there's bound to be people that know about a particular topic, let's say memory safety or like address-based layout or box in the heap and a whole bunch of other things than I do. And so actually sharing knowledge is part of that story. And like in a live stream, I'm very encouraging, like I'm very, very welcoming of people suggesting changes to my code as I go. And I don't know. Hopefully I've answered a couple of those questions that you were asking.
Yeah, I think so. I think the big thing that I was like sort of coming back to is like early on you mentioned, oh, I have this many YouTube subscribers and I see other people with 800,000 or something like that. And the two things I tell, because I've had other people ask me about that, the two things I tell people, or I try to tell myself, is number one, you might just be at a different part in the process. You haven't, you're still early in that sort of journey of growing that thing. But two, you might be playing a different type of game, right? Like people that have 8,000 subscribers, I'm not like, dogging on them or saying anything bad about them, but like they might just, they're maybe they're more entertainment or different things like that. But I'm guessing that, you have 8,000 subscribers, you have this book, Rust in Action, you have a consulting and training company where like people are like, you are very well known of, if I want to upskill my team on this thing, Tim is the person to go to for that specific thing. And I don't think that's going to be true of the person with 800,000. Like, they're playing a different game and just have to realize 100%. That sort of thing. And like, tell yourself, like, what am I trying to do here? What's the goal? And also, where am I at in the process?
Yeah, no, absolutely. So to just kind of reinforce that, there's a couple of things that I have done. One is that I don't play the thumbnail game. So I know that I could do better, immediately like doubling my click-through rate by creating thumbnails which are kind of more traditional. They don't need to be kind of like screaming, like the kind of like face and like, whoa, it's like borrow checkers got me now. And the other thing is, it's like, and like I think it would be kind of good at it. And so maybe I could do that. But I've tried to actually create a thumbnail theme with kind of blocky graphics and kind of this retro computer thing. And I'm trying to just say like, oh, this is a Tim Clicks video. If I've got time, let's kind of like check it out. I don't want to add pressure. I don't want this sense of urgency to come. It's like, it's okay for you to take your time. Like the video is going to be patient. It'll be there when you get back. So yeah, this is definitely trying to play a different game. And the other one is that I'm still learning. I feel like YouTube or like video content is a craft. And I think it demands a lot of respect. And I haven't got enough time in my day. Well, at least I try to produce like a 12-minute video. And like it's taken me 3 days. I'm like, holy shit. That's a lot of time. And it's like, you know what? I'm just going to like upload the thing. If I don't do it, I'm going to drop another 3 days on this. It's going to be like 20% better. And that's not really enough for me. And so I should probably just take it, like cut and run. And so for me, yes, I would love my production quality to be higher. I would love the sound editing to be like, I'd love there's so many things that I would love to do. But right now, where I am in my kind of my journey and my starting my business, and like, it just doesn't pay off. I could pay an editor like $1,000 or something per video. I'm like, well, that's going to cost me shitloads of money over the course of a year. Like, holy moly. And so, but it's been wonderful. Even a video that reaches 10,000 people, like, do we recognize how many people that is?
That's a lot of people. That's like my hometown that I grew up in, you know? Yeah.
Yeah, absolutely. And like that's crazy. And so I need to remember that I'm not actually competing with people. Like, I'm not competing with Fireship. Like, Fireship makes the most wonderful videos and I love them. And I would love to include like memes and like a whole bunch of other fun stuff, but it would totally jar with everything else on my channel. And so, yeah, I don't know. At the moment, I'm just trying to produce stuff that's good, it's helpful, and it's good enough. Essentially, that's my bar, good enough. And yeah.
Nice. Well, Tim, this has been awesome. This is the longest I've chatted to anybody, so I love it. This is great stuff, and I love like all the stuff I learned about Rust, but then also just like the independent journey and creating and doubt and self-doubt, which I have myself and a lot of people do as well. So I appreciate you talking about that. For people that want to find out more about you, read your book, watch your channel, like what's the best way to find you?
Honestly, probably Twitter still, or X, I suppose. So Tim Clicks is the easiest thing to search for. I'm there on YouTube, X, Twitter, Mastodon even, and GitHub if you feel like that too. But and it's timclicks.dev is the website where I try to essentially create like curations of my playlists to kind of enable people to walk through at their own time.
Yep. Great stuff. I watched some of the videos as prep for this episode. It's great stuff. Like I learned a lot of stuff there. So we'll link all those in the show notes. But Tim, thanks for coming on. Like, this is great. I know so many people that really love you in the Rust community. So thanks for all that you've done.
Hey, that's honestly my sincere pleasure. Thanks so much, Alex. Bye-bye.
Bye.